finish by 10 minutes past 9. Okay. If I go beyond that, can someone take a shoe and just throw at me? We clear? Okay, 9:10, you have to go. Understand? It's not fair that you sit down and hear me blare for so long. Okay, so by 10 minutes past 9, we should be done. Right, so today we touch a bit on planar rigid body motion. I will ensure that the recording has started. Indeed, it has. Okay, so if you see where we finished off yesterday, we spoke about what do we mean by planar motion. So just to quickly recap, planar motion, which what we are doing now, if you have to refer to your textbook, is on chapter 16, is the motion is restricted to either XY plane, YZ plane, or ZX plane. So our motion is what? On a flat plane, are we clear? So we are not doing 3D, okay? I don't intend to do 3D for an undergrad course. Maybe I'll take my work back. Let's see how it goes, okay? So the first thing we look at is what do we mean by rigid body, right? So we explain that as a rigid body, point A and point B at any time, okay, will not change its what? Distance. Okay, distance between point A and point B will not and shall never change in distance. Why all this is highlighted? So that these are the operating boundaries. Are we clear? Operating boundaries is what it means is if the motion is planar and at 2 points, it will not change its distance when the structure is in motion, then you can apply what I've taught. Are we clear? If point A and point B change distance during motion, all this theory that I've taught, what can we do with them? Down the toilet bowl. Are we clear? Okay, so as a graduate student or a trained engineer, you need to know when to apply what and why. Okay, good morning. So the first thing we are going to look at is the first part one, where I'm going to talk a bit about the rectilinear translation. So what you can see in rectilinear is the path of motion for any 2 points of a rigid body. Okay, it has to be a rigid body. Are parallel lines. Okay, motion. So as you can see over here, they are both what? Parallel lines. Okay, so that is a rectilinear translation. Then the next one, we have what we call curvilinear. Translation. So as you can see over there is the second diagram on the right row. Okay, so this one is different. This is because the path of motion are along a curved line, which are again over here equidistant. Okay, so the distance between the 2 points along the curve is did not change. Okay. Then the next is rotation about a fixed axis. Okay. So what this case now, when you see if you were to read the textbook and they draw something like this, okay, and enclose, this is what we call a what? Rigid body. Are we clear? If they draw something that's solid and you see in the diagram, all these are our rigid body. So rigid body about a fixed rotation about fixed axis. So the rigid body rotates about a fixed axis. Okay. And all the particles, okay, this is very science-based, within the rigid body moves along a circular path. Okay. So over here, this diagram is posted online. Okay. So this axis over here, we call it the rotation axis. Another name for it is instantaneous axis. Okay. Now, except, okay, those particles along the axis of rotation or instantaneous axis. Okay, the particles or these particles are not rotating. Okay. And lastly, right, so at the instantaneous axis, it's not rotating at all. Okay, it's like Earth, we also have a what? Our instantaneous axis. Along the axis, okay, nothing rotates. And lastly, what you can see in the last diagram on the right column is our general plane motion. So in a general plane motion, like what you see in the diagram, on the right column is the particles in the body undergoes both translation and rotation. Okay, so the particles both translation and rotation. Okay, if it's under, and we will handle some problem and this course under the definition of general motion. Okay. Right, then we're going to go in and analyze what we have in translation. Okay, so if we were to go to yesterday's notes, I post some diagrams. Okay, if you can leave this diagram, okay, I'm going to use this diagram. Right. So when you see a diagram like this, don't like, okay, it's a diagram, whatever. Okay, I used to be like that. Okay, I don't need to cultivate the habit that I have. I regret it when I grew older. Even up to today, I grow older. I regret it. Okay, so don't just look at the diagram and say, okay, this is a figure, move on. No. Okay, so on the over here, we have the what? You have this diagram, yes or no? Yes. Okay. So over here, you have a fixed coordinate system. Fixed coordinate system means by all means, this coordinate system will not move at all, i.e. this is your frame of reference. Are we clear? Okay, it will not move at all. And then the next one is the translation coordinate system or the translating coordinate system. The translating coordinate system is relative to point what? A. Wherever point A moves, the translating coordinate system moves along with it. Okay, so now we are not going to look at rotation. We purely look at translation. Can anyone tell me what is this thing over here that they color? What is it? I know it's straightforward, but I want to hear from you. What is it? It's a rigid body. Are we clear? Don't just go, oh, it's just a color, whatever, I don't care. No, it's your rigid body. Rigid body means what? Point A and point B are what? Fixed. Are we clear? Okay, so this is our rigid body. Or not, when you see this diagram down here, you must be wondering, maybe I don't pay the textbook enough money, they got not enough coloring. Are we clear? That's not the case. Okay, it is our rigid body. Okay, so we are going to define, we're going to define the fixed, okay, fixed coordinate system, okay, in space. Okay, I'm just following textbook. Use the word in space, make it sound sophisticated. Okay, it's bullshit, but anyway. Then the translating coordinate system is fixed to the rigid body at point A. Okay. So if we want to know, okay, if we want to know what is RB, okay, so this is equal to RA plus by RB from point A. Okay. Now B over A, you can see this term over here, right? It means position of point B from point A. So basically point A, if B over A means this is your what? Reference. Are we clear? In fraction, everything at the denominator is the what? Is the reference number. Are we clear? Okay, likewise for this. Now, if we were to look into velocity now, okay, if we were to look into velocity, I will get that diagram. Okay, wrong keyboard. Okay, same diagram. Okay, we're going to look at velocity.